Okay, in this video I'm going to continue on with exercise 4b of the book Fundamental Applied Mathematics. We're on page 105 and the question is 17. This is, in my opinion, one of the better questions I suppose that we've come across so far. It states two planes are flying on straight courses at the same height above ground level. Plane A is travelling at speed 500 km an hour. Plane B is travelling due north at 400 km an hour. At 1500 hours, plane A is 60 km due east of B and is on a course which will result in a collision with B. And we're asked to find a big load of things. So the first thing I'm going to do is draw my y-axis, and then I'm going to draw my x-axis, which make my xy or Cartesian plane. Then I'm going to draw the plane B. Now I'm going to tell you that you can move your xy plane around, and it doesn't matter where you put it. So I'm going to put it so that where B is at this particular moment is my origin. And B is going in a northerly direction, like so. That means, of course, that if you were in an aircraft or in space and you're looking directly down at plane B, it would be going north. So that is actually VB. Then we need to draw the velocity vector of A. Now we're told A is 60 kilometers due east of B. So this is B, or this is A here. And we're told it is on a collision course, which means the rough direction for the velocity of A is like that. It must be like that. The next thing we're told is that they're on a collision course. Alright? Yeah, because that's why it has to go in that direction. So we're asked to draw a diagram showing the relative positions of A and B at 1500 hours. That is what I have in front of you. So that's VA. The next thing we're asked to do is what is the direction of the velocity of A relative to B? So let's just do that quickly. So VAB, that's the velocity of A relative to B, is mathematically VA minus VB. But crucially, the point here is that means that B is in a frame of reference whereby it believes that it is stationary and that A is the particle which is moving. So yeah, so that's pretty straightforward. Now let's put in a piece of information which we know. We know that the magnitude of the velocity vector B is equal to 400. Alright? And we know what the velocity vector A, its magnitude is. So if we go for the magnitude of the vector VAB, like so, it is pretty straightforward, okay? Because if we look at this, if we just rearrange this, if we go VAB plus VA, or VB, excuse me, is equal to VA. So if we want to get the magnitude, it's just Pythagoras' theorem. So we get VA squared is equal to VAB squared plus VB squared. Alright, that's just Pythagoras' theorem. So in this case it means that we have VA was equal to 500, so we have 500 squared is equal to x squared plus 400 squared. And x will turn out to be 300 kilometers per hour, which is correct. That's the first thing. So now we're asked to find the direction of the velocity of A relative to B. So how are we going to find that out? We know its magnitude, so we need now to find out the actual velocity vector VAB, and that's quite straightforward to do. Alright, so I'm just going to note down here, just 1 second, VAB is equal to 300. So what else do we know? We know, of course, that VAB is VAB. Oh yeah, because we're talking about, we're saying that B is stationary and A is moving. Now, if we're talking about a frame of reference where B is stationary, the only way in which a collision can occur is if that VAB is along the x-axis. So this must be VAB, and I'll tell you why. Because if we're talking about VAB, then B is not moving, and therefore if they're on a collision course, VAB must move into it. So just to kind of, we'll say, maybe illustrate that, if we use another Cartesian plane here, and we have the point C and the point, we'll say, D here, like that. Now if I say to you that the velocity vector VDC is like this, this is VDC. So in this case, C is stationary. So if this is C, what he will, although he is actually moving, what he will say is that he is stationary and he sees D move across him like that. Alright? Now the only way, for example, in this case, that they will be on a collision course is if VDC actually was going straight for C. Alright, so if we apply the same principle here, we know where B is because it is at the origin, therefore VAB must be in a direction directly towards the origin. And that means, of course, that it does not have a y component because it's just along the x-axis. So we can say this. So VAB was equal to 300 I hat, because that was its magnitude, is equal to VA, which we don't know, but we know its magnitude. We'll say it's xi hat plus yj hat, because we don't know what it is, but we know the magnitude of that vector. We know, of course, that x squared plus y squared rooted will give us 400, or in actual fact it will give us 500, excuse me. And we have to take away 400 j hat, like so. Alright? And what will that give us? I'm sorry for rubbing that out there. That, of course, will give us that x is equal to, is this right here? X is equal to what? VAB, oh, it's a negative, sorry, it's a negative 300 because it's going in the opposite direction to the unit vector, so it's negative 300. Therefore, x is going to be equal to negative 300 I hat, and y is going to be equal to positive 400 j hat. So we can say the vector VA is equal to negative 300 I hat, positive 400 j hat. So let's just sketch that vector. It's negative I and positive j, so it's in the direction I've already drawn it, which is correct. So if we want to get the angle at which it's moving, theta, we just need, of course, to get the tan of this vector here. So it's going to be tan theta is equal to the opposite over adjacent, so 400 over 300, and that's going to work out at an angle which you're going to find out now. So shift tan 4 divided by 3, 53.13 degrees, so I'll say just 53 degrees. So theta here is equal to 53 degrees. Alright, so now we've worked out the velocity vector VAB, and we know its magnitude. So what else are we asked to find out? We're asked to find out, okay, we've got its direction, okay, and VAB. Yeah, we know the vector VAB, of course, was negative 300 I hat. That's its direction. We're asked to find that out too. So the last thing we're asked to do is to find out the time at which the collision will occur. Now, I believe that there is a typo in the answer to this question. So look, we're saying that we're dealing with VAB, which is equal to VA minus VB. And crucially, that means that B is in a frame of reference whereby it is stationary. And we're after saying that VAB is equal to negative 300 I hat, and that they're on a collision course. So if B is stationary, or in a stationary frame of reference, the only way in which particle A can reach B is by traveling along the x-axis. So it must be the distance, which is 60 kilometers, and we're given that, must be covered by something moving in the I hat unit vector direction, or the x-axis. All right, because it's an x-axis or distance, so it must be an x-axis velocity in order to cover it. Okay, so for that reason, this is going to be 60, your distance, 60 kilometers, divided by your time. All right, so 300 kilometers an hour. So what you're going to get is 60 over 300. Okay, which gives you a fifth, which is 0.2. That's 0.2, 0.2. All right, so it's got to cover 0.2 of an hour. So what's 0.2 of an hour? So if you multiply 60, which is the number of minutes in an hour, multiply it by your answer, and you're going to get 12 minutes. So it's going to be 12 minutes. Alright, so it's going to be 12 minutes. And we're told that the whole motion starts at 1500 hours. Therefore, of course, the collision must occur at 1512. So, in actual fact, there isn't a typo. I don't know what I was thinking about there. Alright, so 1512 hours is correct. Alright, so that was pretty straightforward. Thanks for watching. Please pass it on to your friends and subscribe to my channel.